Okay, first thing we have to do here on example number 4 is change the cosine of x to a cotangent x here on the left. So sorry about that. Small typo. So you should have a tangent of x plus a cotangent of x is equal to a secant x times a cosecant x. So sometimes it is more conducive to simplifying these identities if you change everything to sines and cosines. So what we're going to do is we're going to simplify what is on the left side of your equation. So if we start with a tangent of x plus a cotangent of x, so this is your left side, we can turn the tangent into a sine of x over cosine of x. And if you have a cotangent, that is a cosine of x over sine of x. So now in order to have a common denominator is going to end up being sine x cosine x, sine x times cosine x on the left. So what we're missing on the left is we are missing, in the left fraction, you go from having a cosine x to a sine and cosine, so we are missing a sine of x. So you need to multiply top and bottom by sine of x. And when you do that, what you get on the top is a sine squared x. And then on the right, what you're missing is a cosine of x. So you multiply those together, you get a cosine squared x on top. Well, if you remember from one of our properties, we know that sine squared x plus a cosine squared x is equal to a 1. So what we get up here on top is a 1 over sine of x times cosine of x. So we're still simplifying the left side. And what we can do here then is if we have a 1 over sine of x cosine of x, you can actually split this up into two fractions because each of these is over a, or is underneath a 1. I know, weird. Splitting up a fraction. A little weird. But what happens then is if you have a 1 over sine of x, that is equal to cosecant of x times 1 over cosine of x equals this right here. And I apologize, I didn't write that correct. Let me erase this here on the left. Maybe. Maybe? No? Sorry, so let me redo that. So 1 over sine of x is going to give you a cosecant of x, and a 1 over cosine of x is a secant of x. So this is equal to what we had on our right hand side, which is a secant of x times cosecant of x. So now you have proven that your left hand side is equal to your right hand side.